Boom! Greetings, nerdlings. How is everybody? Yes, my name's David and welcome to Studio 64. I've been searching the interzones for more science, space and tech to share with you. Came across this at phys.org. Yes, scientists discover phenomenon impacting Earth's radiation belts. This should be interesting. Very interesting indeed. Yes, two University of Alaska Fairbanks scientists have discovered a new type of whistler, an electromagnetic wave that carries a substantial amount of lightning energy to the Earth's magnetosphere. Interesting. The research is published today in Science Advances. Yes, Vikas Sunwalkar, a professor emeritus, and Armani Reddy, an assistant professor, discovered the new type of wave. The wave carries lightning energy, which enters the ionosphere at low altitudes to the magnetosphere. The energy is reflected upwards by the ionosphere's lower boundary. It is about 55 miles altitude in the opposite hemisphere. That's really interesting, isn't it? Absolutely fascinating. Let's have a look at that. Absolutely amazing. Yeah, really interesting because, as I say, I'm not a scientist myself. I just love all science, and I think this is particularly interesting. So if there are any atmospheric scientists out there, please feel free to comment on this video because we'd love to hear from you. It was previously believed, the authors write, that lightning energy entered the ionosphere at low latitudes. Geez, I can't even speak today. Remained trapped in the ionosphere and therefore was not reaching the radiation belts. The belts are two layers of charged particles surrounding the planet and held in place by Earth's magnetic field. Now, we as a society depended on space technology, Sonwalkar has said. Modern communication and navigation systems, satellites and spacecraft with astronauts aboard encounter energetic particles of the radiation belts, which can damage electronics and cause cancer. Very interesting indeed. Having a better understanding of radiation belts and the variety of electromagnetic waves, including those originating in terrestrial lightning, that impact them is vital for human operations in space, he said. Now, Sonwalkar and Reddy's discovery is a type of whistler wave they call a specularly reflected whistler. Whistlers produce a whistling sound when played through a speaker. Now, lightning energy enters the ionosphere at higher altitudes, reaches the magnetosphere as a different type of whistler called a magnetospherically reflected whistler, which undergoes one or more reflections with the magnetosphere. This is absolutely amazing. The ionosphere is the layer of Earth's upper atmosphere characterized by a high concentration of ions and free electrons. It is ionized by solar radiation and cosmic rays, making it conducive, and crucial for radio communication because it reflects and modifies radio waves. That's really interesting. Very interesting indeed. Again, not a scientist, just absolutely love all science. I think it's fascinating. Earth's magnetosphere is a region of space surrounding the planet and created by Earth's magnetic field. It provides a protective barrier that prevents most of the solar wind's particles from reaching the atmosphere and harming life and society. Sonwalkar and Reddy's research shows that both types of whistlers, specularly reflected whistlers and magnetospherically reflected whistlers, coexist in the magnetosphere. Now, in their research, the authors used plasma wave data from NASA's Van Allen probes, which are launched in 2012 and operate until 2019, and lightning data from the Worldwide Lightning Detection Network. They developed a wave propagation model that, when considering specularly reflected whistlers, showed the doubling of lightning energy reaching the magnetosphere. That's interesting. Review of plasma wave data from the Van Allen probes showed that spectacularly reflected whistlers are common magnetospheric phenomenon. The majority of lightning occurs at low altitudes, which are tropical and subtropical regions prone to thunderstorm development. This implies that specularly reflected whistlers probably carry a greater part of lightning energy to the magnetosphere relative to that carried out by magnetospherically reflected whistlers, Sonwalkar said. That's absolutely amazing. Yeah. You never think about it. You think of a storm and lightning and thunder and rain, but you don't actually have to think about the the lightning itself, and the amount of energy that it could have. It's fascinating. The impact of lightning-generated Whistler waves on radiation belt physics and their use in remote sensing of magnetospheric plasma has been researched since the 1950s. Sonwalker and Reddy, with the Department of Electrical and Computer Engineering in the UAF College of Engineering and Mines. Reddy is also affiliated with the UAF Geophysical Institute. Sonwalker and Reddy sounds like a law firm. It sounds. I was going to say, if it was Luke Skywalker and Helen Reddy, that would be entertaining. Look up Helen Reddy if you don't know who she is. She's an Australian singer from the 70s. And make that Skywalker. That would be quite funny. A law firm made up of a 1970s female singer and a character from a science fiction film. That's just... God, you're a weirdo, David. Sonwalker and Reddy's research is supported by grants from the National Science Foundation and NASA EPSCoR, the established program to stimulate competitive research. That's really interesting. And that was provided by the University of Alaska Fairbanks. Yeah, so scientists discover phenomenon impacting Earth's radiation belts. It's very, very, very important research there, because, as I say, I'm not a scientist myself, but I recognise what they're trying to let us know here. This implies that speculatively reflected whistlers probably carry a greater part of lightning energy to the magnetosphere relatively to that carried magnetospherically reflected whistlers. By magnetospherically connected whistlers, reflected whistlers. Yeah, so different power amounts in that lightning, depending on where it is. Absolutely fascinating. Absolutely fascinating. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. And if you're up for it, drop a comment down below the video, because I'd love to hear what you think. As I say, not a scientist myself. I just love sharing all science, space and tech news. And as I say, anybody knows more about it, please feel free to comment, because we'd love to learn and hear your thoughts. All right, well, as I say, if you can't be good at it. And as I also always say,
my nipples are very sensitive.